Hello again. I am Cristina Borca, and I will provide you technical support for this webinar. Our special guest for today is Mrs. Professor Carmen Teodosiu, professor at Gheorghe Asaki Technical University of Iași, Romania. Hello, Mrs. Teodosiu. Can you hear me?
Good afternoon to everybody. Thank you very much for your invitation.
Okay, I will start with a short presentation about your activity, if you allow me. Mrs. Professor obtained a chemical engineer degree at Technical University of Iași and has a lot of other diplomas, Master of Science, both of International Institute of Hydraulic and Environmental Engineer, University Delft, Netherlands. Also, her research interest is in advanced wastewater treatment, integrated water resources management, environmental assessment, and sustainability. And today, Mrs. Professor, we will tell us something about circular economy applied to wastewater management. And Mrs. Professor, please, you may start your presentation.
Thank you very much for introducing me. This presentation will actually be based on our research in a group that I coordinate at the Technical University of Iași. And we are going to talk about the challenges of circular economy applied for wastewater management, then something about our experience in the complex research project SUSTENF-PRO, a few things about the experimental work for using waste biomass for removing priority pollutants from wastewaters, and few conclusions. When we are talking about circular economy, the tendency is to think about zero waste and also the use of waste as resources. And there are a few concepts that are very important, such as the consideration of products and processes from the manufacturing to consumption and recycling. So this design of processes and products with the use of a biodegradable component or a component that has 100% recycling potential, or the sustainability principles that are applied all over this circle, and the life thinking assessment and management. From the point of view of the systems, the circular economy approach is providing the, let's say, strong sustainability in terms of concept, but also in terms of results. When we are talking about the wastewater management, we are talking about very complex systems from 2 points of view, from the natural system point of view, but also from the anthropogenic system point of view. And we have based all our researches on the water use cycle approach, which is considering the water from abstraction up to discharge or recycling, with the phases for drinking water treatment or industrial water treatment, then wastewater collection, wastewater treatment, and finally what can be done to safely discharge the wastewater or to reuse it. So apart from all the constraints that and the challenges that we have related to the natural system, that are impacts, risks that are related to climate change events and so on, we also are facing some constraints related to the anthropogenic systems, and one of them that is very important is also the fact that we have various stakeholders with various interests and various backgrounds that are expecting information and decisions within these systems. Talking about the circular approach in wastewater management, there are mainly three types of approaches that are at the moment used. That is wastewater recycling and reuse after advanced wastewater treatment for industry supply, for irrigation, or for urban use, or for other uses. Another approach is considering the waste materials that are used in various wastewater treatment processes, or the wastewater sludge valorization for resources or for energy recovery. From this point of view, if we are talking about the wastewater line and the advanced wastewater treatment processes, we see that as far as we go within the improved wastewater quality, we will find a variety of processes from conventional treatment, like mechanical treatment, physical, chemical treatment, biological treatment, but also more important when we are thinking about recycling and reuse of wastewater, we are considering advanced treatment. And as far as we go on the treatment line, we will obtain better wastewater quality, better removal efficiencies, but we will have also encounter within this process, we will encounter technical challenges, we will encounter problems about costs, and most important, energy requirements that are increasing, and other types of issues like the sustainability assessment of these systems. From this point of view, basically, I have tried a bit to tell you, let's say, the overall background. From this point of view, we have started when we have conceived this project. It is a complex research project that is called SUSTENF-PRO as acronym. Actually, the full name is Integrated and Sustainable Processes for Environmental Cleanup, Wastewater Reuse and Waste Valorization. It is a project that we are running, we are implementing in a consortium form of 6 partners. We are leading this project, but we have as partners Polytechnica University of Bucharest, we have Polytechnica University of Timișoara, Petru Institute of Macromolecular Chemistry from Iași, Alexandru Ioan Chiuza University in Iași, and the National Research and Development Institute of Environmental Protection from Bucharest. So all coming with various experiences, research experiences, all coming with a very interdisciplinary background. Our project objective is focusing on the increase of institutional performances of all institutions in the environmental field. We are trying to consolidate our research in partnership. We are trying to consolidate collaboration, and we are also trying, apart from the senior researchers, we are trying to get into research and to train young researchers. And most important, we are also trying to be very focused on application and the innovative potential and transfer towards wastewater treatment operators. So the research directions of this project are focused on the priority pollutants. And we have considered priority pollutants because at the moment when we have started our project, there were only few researchers in this field. They are very important both at the European Union level scale, but also at the international scale. The priority pollutants and the emerging pollutants are nowadays one of the most studied type of pollutants all over the world. Apart from the monitoring in various water and wastewater matrices, we have focused our attention in this project towards drinking water treatment, wastewater treatment with the valorization of biomass or metallic waste for different processes. And last but not least, we have tried very much to focus on the sustainability assessment of these treatment processes and waste valorization processes, which is bringing also a new approach in the, let's say, current landscape of research in this field. You may see here the project concept based on the water use cycle, as I have mentioned previously. We are focusing our research within 5 component projects that are running in parallel. This is quite tough. And from this point of view, the projects are, let's say, standalone projects focusing on quality of surface water that is supplied for drinking water treatment, then drinking water treatment innovation and use of different materials that will make the process more efficient, wastewater treatment, and finally, we have this project that is dealing with sustainability assessment that is connected with all the other component projects. The component projects, as I have mentioned, are done in partnerships. So we have usually 5 or 6 partners at each component project. We have a leading partner in each component project. And mainly our desire was to go at the for some, you see here also mentioned the technology readiness level at the beginning of the project and at the end of the project. We have mostly tried to go towards processes that are already let's say optimized at laboratory scale or at the pilot scale. And this is a bit the introduction until the valorization of rapeseed waste for wastewater treatment. We have used rapeseed waste because it's coming from oil or biodiesel manufacturing processes. There is quite rapeseed production in Europe, but not only in Europe, also in other countries like China, Canada, India, and so on. And the rapeseed have several particularities that is making it good for or is conferring it the quality of a low-cost biosorbent. So the lignocellulosic fibers and proteins provide these functional groups like carboxyl, hydroxyl, and amine that make biosorption process efficient through various mechanisms, either through ion exchange or complexation or electrostatic interactions and so on. We have started our experiments from 2 target priority pollutants, the lead ions, this is a heavy metal, and the reactive blue 90 dye. This is an anionic dye, usually being encountered, both components being encountered in industrial wastewaters, but not only. The experiment started from the single biosorption processes, then moving forwards towards sequencing biosorption, simultaneous biosorption, and we have tried in all the cases to come up from the, let's say, establishing the equilibrium conditions, then moving on to kinetics, of course, characterizing the materials, and afterwards determining the selectivity and other removal efficiencies and so on. It is important also to mention the fact that we have tried to use the waste with a minimal preparation because we have considered that very a very complex use of waste, or very difficult types of using the waste would make the process more difficult. You see here the layout of the sequential biosorption processes. We have tried to approach these kind of processes in various ways, trying first to absorb on the rapeseed the lead, and then the dye. On the other hand side, we have also made experiments with the dye, absorb the dye first and then the lead. It is important to mention that we have tried to be as much as possible in the pH range of wastewater treatment as it is in the plant. And also we have tried to use the initial concentrations as much as possible in the level of concentrations usual for advanced wastewater treatment. We observe in the sequential biosorption processes, we observe that the increase of lead concentrations also favor biosorption. And from this point of view, we may observe that sequential experiments are quite similar to individual experiments, and we may also observe from the X-ray photoelectron spectroscopy, we can observe also that the lead, both the lead and the dye, are absorbed into the biosorbent. For the simultaneous biosorption, our idea was to go closer to the real wastewater treatment applications. So usually wastewater are having quite a number of pollutants inside, and we have tried to approach, let's say, the real cases, of course, doing still a lot of experiments with the equilibrium, with the kinetics, the selectivity, and the sorption studies. From this point of view, it is important to mention that when we are talking about selectivity, and selectivity is an important issue in wastewater treatment when we are using biosorbents, we may observe that actually selectivity studies showed us that the higher the concentrations, the selectivity is not really very good, while when we have, let's say, moderate concentration of both lead and dye, we may go for a good selectivity. What we have observed also in the simultaneous biosorption is that the lead is usually helping the biosorbent to remove more of the dye, which is actually a fact that we have seen in the sequential biosorption as well. Comparing them, because we are dealing mostly with very practical questions. So comparing the sequential biosorption with the simultaneous biosorption, apart from the minimal preparation, apart from the operating conditions, we observe that there is quite an important removal of efficiency both in the sequential process and in the simultaneous process. And we observe that both the lead and the dye are removed up to 80-85% or 90-95% for both types of processes. It is also important to mention that the biosorbents may be reused, and there is a sort of desorption studies that we have undertaken as well. What about the biosorbents? Of course, this is an important question because in this kind of process, we are transferring waste. We are not destructing the pollutant, we are transferring actually the pollutant in another phase. So what can we do with the biosorbent? This is an important question. We can either use the biosorbent up to its exhaustive loading, and we have seen here in the graph, we have seen some experiments from the sequential biosorption, or we can valorize it as substrate for fungi, biochar production, soil amendment, or recovery of other materials. What we can also do energy recovery, because this is a biosorbent that has quite a good calorific value, and of course, last but not least, landfilling it in controlled conditions. One of the big issues about the practical implications of the biosorption process is to go from the laboratory scale to pilot scale, and these are the questions that we normally should pose. What would be the reactor design look like? Is it batch or fixed bed column? Most probably the wastewater practitioners would prefer a fixed bed column. Then we have the column clogging problems that may be avoided by adding an inert polymeric design. We can also think about the selectivity studies done at pilot scale and high operating time. So all these kind of questions are very important when we are preparing the transfer from laboratory to pilot scale. So as few conclusions that I would like to mention, we have based our research on this circular economy approach by using a rapeseed waste for biosorption. We have done it from two perspectives, sequential and simultaneous. We have found out that actually lead is always increasing the biosorbent capacity for a further removal of the organic dye. And we found out that the selectivity studies are very important in the simultaneous systems, and they should consider various molar ratios between the metal and dye. Of course, there are the issues of sustainability assessment applied for these processes. That is very important, because if we are thinking only about the technical issues of the process, we are not considering actually the most important principles of the circular economy approach. I would like to finally thank you very much for your attention, and if you have questions, I will be happy to answer them. Thank you very much.
Thank you to Mrs. Professor Carmen Teodosiu. So we now open the question session. We have around 5 minutes left. Seems to be no question yet. I think everything was very, very clear.
Hopefully.
Okay, since we don't have any questions, I would like to thank you again for your participation, and with your permission, I will disseminate one of our sponsor promotional video It's about Grundfos company. And thank you again. And we invite you to follow us for the next webinars.
Thank you
Okay.
very much. Thank you very much. Thank you.
Thank you too.